Good day, ladies and gentlemen. Welcome to Code Switching 2020, where we continue with our grade 12 physical sciences, looking at electric circuit. This will be our second question. So let's start. Please pause the video and try the question. Then after, check the solutions if you got it correct. So today's question is as follows. Number 1. Given that the amp of the battery in the circuit is 15.58 volts and internal resistance is unknown, the reading on the ammeter is 1.4 amperes and the voltmeter reading is 15 volts. Question number 1, they said, calculate the total resistance of the resistor M. Question number B, calculate the internal resistance of the battery. So when we look at our circuit, we are given the amp, which is 15.58 volts, the voltmeter on the battery, the ammeter, which they said is 1.4, and we got two resistors which are in series, which is 2 ohms and 6 ohm. And 2 ohm and 6 ohm is in parallel with 7 ohm. Then we also have unknown resistor, which is Rm. So let's start with the first question. The first question, they said calculate the total resistance of the resistor M. When we look at our statement that we are given the amp, which is 15.58 volts, and we are given the reading on the ammeter, which is the total current, which is 1.4 amperes, and the reading on the voltmeter, which is 15 volts. So since we need the resistor M and we have the total current and the total voltage, we can start by calculating the total resistance. We'll say RT is given by V over I, which is the total voltage, which is 15 over 1.4. 15 divided by 1.4 is 10.17 ohm. This is our total resistance of the circuit. So, the second step, we realize that 2 ohm and 6 ohm are in series. So meaning total resistance in series, we add the resistors, mean this will be 8 ohm. So 8 ohm is in parallel with 7 ohm. So meaning you must start by calculating again the total resistance in parallel for this part. So 1 over R parallel will be given by 1 over R1 plus 1 over R2 plus, depending on how many resistors you are given. Let's say R1 is 8 ohm, which is the sum of 2 ohms and 6 ohm. This will be 1 over 8 plus R2 is 7 ohm, 1 over 7. 1 over 8 plus 1 over 7 is equal to 15 over 56. This is not R parallel, meaning therefore R parallel will be given by 56 over 15. 56 over 15 is the same as 3.73 ohms. So when we add R parallel and Rm, give us the total resistor. So say the total resistor will be equal to R parallel plus Rm. R parallel, we said, is 10.17, will be R total is 10.17, will be equal to R parallel, which is 3.73 plus Rm. Therefore, our Rm will be equal to 10,17 minus 3,73. When we punch on our calculator, we get 6,44 ohms. That's the resistor of Rm. Meaning Rm will be equal to 6,44. Okay. Let's just do a recap on the first question. They said calculate the total resistance of the resistor M. I said because of we are given the total ammeter, the total current, which is the reading on the ammeter, and the reading on the voltmeter, which is the total voltage, is 15 volts. We can start by calculating the total resistor, which is the total voltage over the total current. There we said substitution 15 over 1,4. Then we got 10,17 ohm. Then for us to simplify, we needed to simplify the parallel part on the circuit so that it can be in series with Rm. Then the parallel part, we said 1 over R parallel will be given by 1 over R1 plus 1 over R2 plus depending on how many resistors you are given. Then we said let the sum of 2 plus 6 be R1, which is 1 over R1, 1 over 8 plus 1 over 7, which you got 15 over 56. Then to get Rp, not 1 over Rp, we say 56 over 15, we got 3,73 ohms. Then we knew that the total resistor is the sum of R parallel plus Rm, so that we can get Rm. So we said 10,17 will be equal to 3,73 plus Rm. We transpose 3,73 to the left hand side, therefore Rm was equal to 10,17 minus 3,73, which is 6,44 ohms. That's question number 1. Let's look at the second question. The second question, they said calculate the internal resistance of the battery. For us to calculate the internal resistance, we need to start by calculating the lost volts. The lost volt will be equal to the M, which is 15,58 minus the total voltage, which is 15. The lost voltage inside the battery is 0,58 volts. So the internal resistance will be given by, this is R. The internal resistance will be given by the lost volts over the total current. Our lost volts is 0,58 divided by our total current, which is 1,4. Then we'll get 0,41 ohms. That's how we got our internal resistance of the battery. So, thank you for watching. For more videos, please code switching 2020.